Today in Capechi's Corner, we're going to look at solving radical equations. When we're solving radical equations, we need to isolate the variable, so we need to figure out how to get rid of the radical sign. I have a quick example here at the top that says the square root of x is equal to x to the 1/2 power. So in order to get rid of that radical sign, I actually square it. It's because by squaring it, I take 1/2 to the second power, and when I have a power to a power, I multiply, which would give me x to the first power, which is what I want. So in number 1, I have the square root of c minus 2 is equal to 6. So what I'm going to do is I'm going to square both sides. And by squaring the left-hand side, all I really did was get rid of the radical sign. So I'm left with c minus 2 is equal to 6 squared, which is 36. I had 2 to both sides. So my answer for number 1 is c is equal to 38. Now I'm going to want to check my work there. So I have c is equal to 38, so I'm going to substitute it back into my original. So I have 38 minus 2, square root of 38 minus 2 is equal to 6. So 38 minus 2 is 36. So the square root of 36 is 6, so I'm good. My final answer is correct. Now let's look at number 2. I have the square root of 2x is equal to negative 2. So let's square both sides to get rid of my radical sign. The square root of 2x squared is 2x. The square root of negative 2 squared is positive 4. Divide both sides by 2. So x is equal to 2. Now I want to check this, and you're going to see we're going to have a problem on this one, which we're going to talk about. So the square root of 2 times 2 is equal to negative 2. So underneath my radical sign I have 4. So I'm saying the square root of 4 is equal to negative 2. That's not true. Let's go back to the original. So let's see what happens. So I have the square root of 2x is equal to negative 2. So here's the thing. I have my radical sign on the left-hand side. It doesn't matter what value is underneath. I can't get a negative number. So that's why this is not checking. So this answer is really no real solution. This 2 that looks like we have, that's called an extraneous solution. What that means is when I do the algebra, it works out correctly. I didn't make any mathematical mistakes when solving it. However, when I substitute it back into my original, it does not give me a true statement. Okay, let's look at number 3. Again, I have a radical on both sides this time. So again, I'm going to square both sides. That will allow me to get rid of that radical sign. So I'm left with 3n minus 2 is equal to n plus 6. Bring my n to the other side, and I have 2n minus 2 is equal to 6. Add my 2, and I have 2n is equal to 8. So n is equal to 4. Now we're going to check it, so let's go back into our original, and wherever I see an n, I'm going to put a 4. So I have the square root of 3 times 4 minus 2 is equal to the square root of 4 plus 6. So 3 times 4 is 12, minus 2 gives me 10, is equal to the square root of 4 plus 6 is also the square root of 10. Now I don't have to simplify that any further. I have a true statement, so I know that the answer to this problem is n is equal to 4. In number 4, I have the square root of m minus 1 is equal to 5. I know I need to get rid of that radical, but before I do that, I have to isolate it. So I need to have only the radical on one side of the equation. In the previous problems we have done, that was already there for us. So the only thing I need to do for number 4, before I can square it, is add 1 to either side, because then I have the square root of m is equal to 6. There's my wall, and I have that square root is isolated. Now I can square both sides. So I have m is equal to 36. Now again, I want to check it. So I go back to my original. The square root of 36 minus 1 is equal to 5. The square root of 36 is 6. 6 minus 1 is equal to 5. So I know that m is equal to 36. In number 5, I have 9 minus 4 times the square root of b is equal to 25. So again, here's my wall, and I need to get this square root of b by itself. So the first thing I'm going to do is I'm going to subtract the 9. So I have negative 4 root b is equal to 16. I divide everything by negative 4, and I have the square root of b is equal to negative 4. Now at this point I can stop, because I noticed, like we talked about earlier, I have the square root of b cannot equal a negative number. So this is going to be no real solution. Now if you were to go on and solve that, you would get a value, but if you would check it, it wouldn't work, so that would be an extraneous solution. Therefore my answer is no real solution. In number 6, again, here's my wall. I have negative 6 times the square root of 5k plus 10 is equal to negative 30. So again, I have to isolate my radical sign. So this is negative 6 times the radical there. So I'm going to divide everything by negative 6. So I have the square root of 5k plus 10 is equal to positive 5. Now I can square both sides because I have that radical isolated. So I have 5k plus 10 is equal to 25. Subtract the 10 from both sides, and I have 5k is equal to 15. So k is equal to 3. So once again, I'll check it. So I have negative 6 times the square root of 5 times 3 plus 10 is equal to negative 30. This gives me negative 6. My radical is 5 times 3, which is 15, plus 10 gives me 25, is equal to negative 30. So again, I have negative 6 times 5 is equal to negative 30, which is true. So I know my answer is k is equal to 3. In our last problem for today, we have the square root of x plus 6 is equal to x. So I do have my radical isolated, so I can go right into squaring both sides. So that gives me x plus 6 is equal to x squared. Now, anytime I have the second power higher, I'm going to bring everything to one side and see if I can factor it. So it gives me 0 is equal to x squared minus x minus 6. Now I'm going to factor. I have x and x. My signs are opposite. Factors of 6 that when I subtract I get 1 is 3 and 2. Since my higher factor is 3, that's going to go right there, and then I have a 2 there. So I have x plus 2 is equal to 0, or x minus 3 is equal to 0. So that gives me x is either equal to negative 2 or x is equal to positive 3. So again, let's go back to the original, which was the square root of x plus 6 is equal to x. Now this radical is already isolated, so if I substitute it in, let's see what happens. To check. So if I start with x is equal to negative 2, I get negative 2 plus 6 under the radical sign is equal to negative 2, which is the square root of 4, which is equal to negative 2. So that's a no, that doesn't work. That x is equal to negative 2 is an extraneous solution. Let's try x is equal to 3. So I have the square root of 3 plus 6 is equal to 3. So the square root of 9 is equal to 3, which is true. So my answer in this problem is x is equal to 3.